Kia ora 13 MCA. This is a really tricky trig and differentiation question from March 2019, question 5. So please, if you're finding anything that you're feeling is really quite hard, please do send it in. Barnaby, thanks for this one. It is a lovely, lovely question with quite a few things that you've got to spot in here. So the first thing that you'll notice is that we've got sine of y is equal to tan of x, and we have to show that dy by dx is equal to this. We're going to use some trig identities here quite a lot, and we also have to be really confident with implicit differentiation. I guess the other way you could do it is you could do some inversing stuff here, and then you're still going to end up with something mucky. I'm just having a look at that now. So we could do tan inverse of sine y is equal to x. I might try and do it that way in a separate video, but for now I'm going to do what I did before, and I'm going to use implicit on both sides. So differentiating the left-hand side, first with respect to y gets me cos y, and then by the chain rule I've got to times it by dy by dx. On the right hand side, the derivative of tan x is sec squared of x. There's a times sign there. So that felt pretty easy. Dy by dx is equal to 1 over cos squared x times cos of y. And this is the problem, right? Because in the end, first of all, we haven't got any cos squared of x, but we definitely haven't got any y stuff going on. So if you look back at the question, you'll notice that there's this little hint here, which will help us later on. The only thing that's linking up the y and the x is that sine of y is equal to tan of x. So somehow we have to get cosine of y out of sine of y. Think back to AS. What was the link up between sine and cosine? Well, we've got this. Sine squared of y plus cos squared of y is equal to 1. And that means that sine squared of y is equal to 1 minus cos squared of y. But we know from up here that sine of y is tan x. So in our question, sine squared of y is equal to tan squared of x, just squaring both sides. And that means that tan squared of x is equal to 1 minus cos squared of y. So now we are getting somewhere quite quickly. Cos squared of y is equal to, which way around am I going? 1 minus tan squared of x. Finally, we get an expression for cos of y, but it could have come from either the positive or the negative square root. So let's think about why it has to be just the ordinary old square root thing. Let's draw our quadrant diagram. Think back to level 3 trig, everyone's favourite. This tells us the signs of the different functions. So all of the trig functions are positive here. Only the sine function is positive here, only the tan function is positive here, and only the cosine is positive here. But very conveniently, we were told that y was between negative pi on 2 and pi on 2. So that means that I'm in these two quadrants, so cosine is positive, big yay. That means that we can not worry about the negative, and we know that cos of y is equal to 1 minus tan, root 1 minus tan squared x. Now, I didn't see any of this in the marking schedule, but if I were marking a scholarship calc question like this, I would want to see some kind of reasoning for why we're ditching the negative root. Let's go back to this question though. So we're down to cos of y is equal to this, and back up here we've got 1 over cos squared of x times cos y. So I now need to go and substitute in my fancy new square root thing in here. So I'm going to move over here, and we get 1 over cos squared of x times root 1 minus tan squared x. Now this is still not looking too flash. I don't have a double angle going on in here, and I've still got tan. So I don't want tan. I'm going to go right back to basics and put in the definition of tan as sine over cosine. So I've got cos squared of x here, and then in here I've got 1 minus sine squared x over cos squared of x. And that's going to give me now a fraction with a common denominator, which will be cos squared of x minus sine squared of x. And finally, everything starts to make sense, right? Because I've got 1 over cos squared of x here over the square root of cos squared of x, which is cos of x, times the square root of cos of 2x, because this is my third of my double angle cosine formulae. So we get our result. We get 1 over cos of x times root cos of 2x. So Barnaby, thanks heaps for that question. People who are going really well with their Pure 3 revision, please, for the sake of everyone else in the class, just keep on sending in these tricky questions, even if they're ones where you could follow the mark schedule. If you feel like it was quite a tough problem, then I'd really like to be able to use it with everyone else too.